Welcome to our second chapter. In this chapter, we'll be discussing chemistry. There is a large amount of chemistry you and I will be handling as the rest of this year goes by. We can't discuss any of physiology without chemistry, and a large portion of anatomy needs a basic understanding of chemistry as well. Our main goal as we go through this chapter will really be to get you to four main chemicals that you thoroughly understand, and those would be proteins, lipids, which are also known as fats, carbohydrates, which you may know as starches and sugars, and nucleic acids, especially DNA and RNA. So proteins, lipids, carbs, and fats, something we need to have a discussion about. And before I can get you there, we need to build on a foundation. So we're going to start with this first video where we'll be discussing two main ideas: matter and energy. Our learning outcomes for this video would be to differentiate between matter and energy, as well as the two types of energy, which would be kinetic and potential energy. And we'll have an understanding of those two major forms of energy, kinetic and potential, by the time we're done with this chapter. Let's start off with matter. Matter is effectively anything that has mass and occupies space. Now, I don't want you to get confused on a particular pair of terms that are often used interchangeably. And as long as you're standing on the surface of planet Earth, it's okay to use those two terms interchangeably. And the two terms I'm meaning here are mass and weight. Weight is the pull of gravity on mass. And as long as we're on the planet again, then we can pretty much use these two terms interchangeably. But you always have the same mass. You do not always have the same weight. And this has nothing to do with you losing 10 pounds that you gained over the holidays. If you were to become an astronaut and travel to space, of course, you're going to experience zero G. You would effectively weigh nothing, but you have all the same mass. If you travel to the moon, if you are that lucky, then you would have about 1/6 your total weight, but you would still retain all of your mass. So weight, in effect, is the pull of gravity on the mass that you have. Matter, again, anything that has mass and occupies space, comes in three different states. The three states of matter would be solids. Solids have a definite shape and volume. Think of something like a brick. The next state of matter would be liquid. It has a changeable shape but a very definite volume. Imagine having a 20-ounce soda. That 20-ounce soda in a soda bottle has, at least for the time that's in the bottle, a definite shape, but you can pour that same 20-ounce soda out onto the floor and it completely changes its shape. It becomes a puddle. It still has the same volume, though. Gas is the third main state that we describe matter in, and gas has both a changeable shape and changeable volume. Our next topic, of course, is energy. Energy is the ability or capacity to do work in order to put matter into motion. Energy comes in two main types. The first type we'll talk about is kinetic energy. Kinetic energy is energy in action. Great example there would be sitting at the top of a roller coaster, just that moment before you go over the top, and as you slide over the top and feel that immediate pull, you are experiencing kinetic energy. Now, right before that, as you're sitting on the top of that roller coaster hill with all of that energy about to be released, what you have at that point is potential or stored energy. So as long as you're still at the top of the hill and have not yet gone over the top, it's potential energy. But as soon as that energy becomes action, we're looking at kinetic energy. Energy can actually be transferred from potential to kinetic energy, and our roller coaster is a great example. Another good example is a bow and arrow. If you put an arrow into a bow and pull the string back, that would be, as long as you hold that string, potential energy. As soon as the arrow is released, then it's transferred to kinetic energy. Now, here's one of the first moments I'm going to have you visiting Mastering A&P. What I'd like you to do is go to Mastering A&P. While you're there, go to the upper right-hand corner and click on Study Area. The top bar you'll see shows chapter choices. Choose Chapter 2, click the word Go, and watch the animation called Energy Concepts. Now, energy can come in several different forms. There's chemical energy, which is energy that is stored in the bonds of chemical substances. You count on this to be released when you consume food for energy. So a form of energy that you're probably quite familiar with is energy stored in chemical bonds. Electrical energy results in moving charged particles commonly through wires. Mechanical energy is energy that is directly involved in moving matter, like maybe hitting a baseball with a baseball bat. Radiant or electromagnetic energy you can experience anytime you look at a light bulb or feel heat coming off of a curling iron, or other examples would be ultraviolet light or X-rays. Typically, radiant energy travels in waves. Energy can be converted between forms, and a great example for this would be something like putting gasoline in a car, starting up the engine, and running that gasoline energy, which would be chemical energy, to mechanical energy to drive your car. Energy conversion typically is very inefficient and very often ends in losing a lot of that energy as heat. And with my example of the car, you can understand that when you start your car, the engine gets very, very hot, and that heat energy is lost. A lot of the new vehicle technologies are designed to recover some of that previously lost energy. That's actually going to do our discussion for the day. Nice short video. We'll pick up here next time, and until then, good luck with your studying.